Okay, so ideally this would be a question that would summarize multiple units, and we'll see why in a little bit. Okay, so pretty much this right here, hopefully you had a little chance to read it. This right here is just summarizing the entire graph. So it says the interval for f, right? Oh, this is f. So fun fact, it's not the derivative, it's just f. Is from -1 to 11, and that's the domain. And we can see right here, -1 to the x value right here is 11. Then it says the area is bounded, and they wrote them for us. And it says that the area bounded from -1 to 2, -1 to 2 is 4, and we can see that right here. From 2 to 6 is 3, and we can see that right here. 2 to 6 is 3. And from 6 to 10, it is 2. So we've seen something like this already. And then we see that there is a piecewise function here. H of x is defined from the interval from -1 to 11. And we can see that. And it's given by the piecewise function that includes a g. Okay, so here we have a g function that exists on this side. And then they tell us what g actually is. So this is what I would have written down somewhere on our paper. And it says g of x function ties back to the f function as the integral from 2 to x, given this domain. So all of this, guys, we've actually seen on the previous fear responses, but we're going to see how else they do it. Okay. What I do like to start writing down here, guys, is when x is less than 1, what does that remind you of? Left or right? Left, right? And when it's between -1 and 11, this will be your right-hand side. Okay, so let's go ahead and start on this. So we have, how do I hide this? There you go. So we're gonna go ahead and see the first question. Show that h of x is continuous, right? At x equals -1. So not that bad, but it's still a very huge topic in calculus. So there's 3 conditions for continuity. We actually talked about them on, what was it, Monday? Tuesday? Continuity. There's 3 terms. There's 3 conditions. That, let's go with h. H of c is defined, right? It exists. Or exist. Then we have the next one that says the limit as x approaches c exists, right? On the h of x exists, right? The limit exists. The left and the right are both equal. And the last one, that h of c is equal to the limit as x approaches c on the function that they gave us. So let's go ahead and try this. Here we go. So h of c. So I'm finding h of -1. So I'm going to go ahead and find out, where is -1, on the left or on the right when x is less than -1? Be the left or the right. So this is our function, and it's saying that our value will only be, sorry, where am I at? Okay, so it says that our value at -1, that is included right here. So we're going to use g of x. So in reality, we're going to be using this function that we have here, because -1 is tied up to this one, which says it is from 2 to the x value, which is -1 for f of t dt. Okay, next. This right here, hopefully we remember that this right here is just talking about the area under the curve. Let me zoom this in. It's bad. Okay, but there is one condition that we need to see, and that is because of the interval being bigger at the top, we need to flip that around. That's a property of the integration. So it's now -1 to 2 for f of t, f of x dx. So we're looking for the area, right? The area in the interval, well, the negative area, right? The negative area in the interval from -1 to 2. So we're going to look at our graph from -1 to 2. From -1 to 2, it says it's 4, right? Right here it says it's 4. But it's asking us to find the negative area because we flipped the interval. So our area should be -4. So this right here, f of c, is -4. And the next condition we're going to meet and check is the limit. Does the limit exist as you approach -1? Well, at -1, the limit as x approaches -1 for the function s of -1, you have to check the left-hand side. Does it equal to the right-hand side? Right? Because that's the only way it exists, that the limit exists. So on the left, I checked this out, and I got that the left here, -1, is this function right here, x squared plus 3x minus 2. So the left going to be, substitute the -1, square it, plus 3 minus 1 minus 2. So I got 1 minus 3 minus 2. So this should give me -5 minus 1 minus -5. Sorry, 1 minus 5, which gives me a -4 for the left. So if it gives me -4 on the left, and this right here, the right, is this function right here, which is what we did for g of x, they're both equal to negative. They're both equal to -4. Because this right here was also the right-hand side. Sorry guys, I'm struggling with this.
Not way too fast.
Okay, so pretty much what I want is that we are checking the left-hand side and the right-hand side for the limit to exist, right? That's how we check limits. But on the right side is defined by g of x, and g of x is this entire function right here. This one right here. So the limit exists and it's -4. So both of them are -4. So we would just write h of x is continuous at x equals -1 because it how do you call it? It meets the requirements of this limit. I'm sorry, because it meets the requirements of this continuity. And I'm running out of space, guys. Because it meets the 3 conditions of continuity. And also in the the post from yesterday, I also posted another video of a different teacher doing it also. Okay. Any questions on this so far? This is just continuity. The only hard part is I'm struggling to show the graphs here, but ideally they should be okay. It's gonna help me a little bit. There you go, that can work. Okay, so let's go ahead and go to the next one. The next one's saying find from least to greatest, right? This right here, h. So letting me know. So So it's saying that we need to go ahead and find the order from least to greatest on H prime, double prime, H double prime of 2, and H double prime of 10. So, well, do we have just H itself? What we do, it's this one right here. So if I told you, hey guys, let's go ahead and find H prime of X, well, that means we derive this right here, the left-hand side and the right-hand side. So if I go ahead and derive the left-hand side, which is this right here, right? It's going to be 2x plus 3. And then the interval stays the same. If I derive g, I get g prime of x. Same interval, -1 and 11. And they want the second derivative. So it's going to be h double prime of x is equal to the same thing. I derived the left-hand side, right? Sorry, I'm running out of space here. So it's the left-hand side is the 2x plus 3. I derive it. That gives me just 2. What in the world? It gives me just 2. And this will be g double prime. And the intervals stay the same. Okay, any questions so far? Well, then I have a question. If this is g, what the heck is g prime? Well, I know what g is. It's all of this. So if I derive this, this is a fundamental theorem of calculus. I go ahead and just get f of x, right? So that means the first derivatives, if I want 2, I go straight to 2. If I want 3, I go straight to 3, and I get that height. If I want 10, I go straight right here, right? And if I want 11, I go straight right here, and I get that y value. But unfortunately, what they want g prime. So g prime of x, it's a double derivative. Where's my eraser? It's a double derivative. So that means it is one more derivative of this f, so it's going to be f prime. So what the heck is that talking about? Well, f prime means the slope, right? The slope of f, because this is f, and f prime will be the rate of change, right? The slope. So let's go at this 6 right here. The slope I would have to calculate, but it looks positive. At this value right here, what is it? 2, 3, 4. It looks like it's horizontal. You know what I mean? So let's go ahead and do this. So where to copy paste this? Nope. Okay, so let's go ahead and do this. It says H. Just kidding, I can't write anymore. H double prime of -2. First, I find out where in the world it is in my intervals, because I have all of these different intervals right here. So my h double prime, I'm looking at this one, is -2. -2 exists only on the less than -1. So according to this, the left-hand side is 2. Super easy, not that bad. But notice how we did have to go ahead and think about what the heck is it really asking. Okay, let's go ahead and check the next one. It says h prime of 2. So I go ahead and check it again. H prime of 2. Where is 2 in my intervals? So 2, positive 2 is on between the interval from -1 to 11. So I'm going to be doing g prime, double prime, sorry, which means this right here. So I need to find the slope at x equals +2. So at x equals +2, not the height, because that would be f, but the slope. So we would have to find the slope right here. Well, all I know about that slope, guys, because I don't know how to figure it out because they didn't give me heights at all, right? There's no y values here. All I can do is say that slope is negative. Any questions on that, guys? Because this slope right here at x equals 2 is negative. It's decreasing, right? If that was a roller coaster, you would be sliding down, or you would be going down. I think I've talked a little too much. Should I slow down, guys?
Seriously, slow down.
Okay, you guys got to tell me, guys. But are we seeing where I'm getting the values from? They're telling me I need h double prime, so I derived this function twice, and I got this one right here. And then, unfortunately, this had the piecewise function to g, so I jumped back to this one, and I derived it twice. So for the first one, no big deal. It's a -2. -2, if I derived it twice, this function here, I derived it twice. It gave me a 1, and then it gave me the second derivative. It's just 2. No big deal. However, the next one said at -2. At -2, I checked my function, and it landed in this interval right here, which means g double prime, which is this one right here, which means the slope of f. And all we knew is that it's negative. Last but not least, h double prime of 10. That means in reality, it's talking about, it's in the interval. Whoopsie daisy. It's in the interval right here, the same as 2, because it's bigger than -1 and smaller than 11. So I'm talking about this interval, which I derived this function twice, and I got this one. So I want the slope f prime of 10, the slope at 10, which looks like it's a horizontal line. That's pretty nice because the other one was negative, the other one was positive, and that makes it easy to. So there's a horizontal slope, so the slope would be 0, right? So in reality, you have from smallest would be h double prime of 2 because it was negative is less than h double prime of 10 because it's 0, and less than h double prime of -2 because that was a positive number. Any questions on that, guys? Questions, guys?
So, can you like go over that? I don't even know what I just.
Okay. Do you understand where I got the slopes? Do you know where I got the
Barely.
2, the negative, and the 0?
Nope. Actually, no.
Okay. So pretty much we're trying to find out where the slopes are coming from. So it's telling me find h double prime of -2. I don't know double prime, but I know h, right? So I derived it twice. Did you get the same thing here? Did you get the same thing for these right here?
The 2 and all the other stuff, yes.
Yep. Yes, so if it is on the left, it's automatically a 2. If it's on the right, well, unfortunately, you're gonna have to check g double prime, but it's okay because we can derive this twice, right? This is g prime, and this is g double prime. However, they're associated with f's. If I derive the integral, I just get the function. If I derive the function, I get the rate of change of the function. Does that make sense? So we can't find it since it's no heights are given, but we can see that its slope is down and the slope is horizontal.
Okay.
And they're just asking you to list them from least to greatest. So they're not telling you, hey, go ahead and tell me exactly what the slopes are. The only slope we were able to find is this one right here.
10.
10 was horizontal. Yeah. So that was 0. The only one we couldn't find is at 2 because it's just a slope down. This is just the same thing. I just copied and pasted because I didn't want to go ahead and keep scrolling up, so I screenshotted it. But it's the same question, guys. Okay. So let's go ahead and do the next one. Okay. So we have the following here. So we have the limit as x approaches 6. So the first thing you should always do, guys, is evaluate the limit. See what happens. So if we evaluate this limit at 6, what does it tell us? Let's go ahead and try it. So with direct substitution, dang it, I can't write. Direct substitution. So with direct substitution, I substitute the 6 into everything, right? So I get g of 6 plus 3e 12 minus 2 times 6 divided by x squared, which is 6 squared minus 36. Okay. I already see one dilemma in the denominator, 6 squared minus 36. Hopefully you're seeing that that is going to be division of 0, but let's check the numerator just to be safe. And it says g of 6. G of 6. What the heck is that? Well, that ties up to this right here. It's actually this function right here, right? It says the area, right? The integral is area. The area from 2 to 6 on the f function. So what is the area from 2 to 6 right here? It's 3, right? But it's below the x-axis. So what does that tell me about my area? It's negative, right? So it's already -3, right? All of this was -3. Am I going too fast, guys?
A bit.
Okay. And then 12 minus 2 times 6 is 12, right? Because 2 times 6 is 12. Okay, so a little bit of algebra here. -3 plus 3e raised to 0 because 12 and 12 subtracted 0 divided by 0. And then we have -3 plus 3. So I got 0 over 0. Okay, so my limit is in this indeterminate form. What can we do? Something really cool that we can do. You remember L'Hopital's rule or L'Hospital's rule?
What's that E0?
The e to the 0, remember, is a number. A number to the 0 is just 1. So e to the 0 is just 1 because 12 minus 12 gave me 0. Does that make sense?
Okay.
Yeah. So then I got this right here. So it tells me, hey, you can do L'Hopital's rule. Cool. So what does that mean for us? What does that mean for us? Well, it's actually telling us, dang it. It's actually telling us that we can go ahead and do the derivative, right? Do the derivative of the numerator, derivative of the denominator, and everything's good. So if I derive this right here, the numerator, right? If I derive the numerator, I should get something like this. G prime of x plus this derivative right here. Well, that's where I think some of us are going to get confused, but it's not that bad. This right here, guys, is derivative of an exponential. Derivative of exponents, right? If this was e to the x, what should we do? Well, we derive it, copy paste it, and derivative of the exponent. So we do the same thing, copy paste it, e 12 minus 2x, right? The same exact thing. But then you derive the numerator. I'm sorry, the exponent, which is this right here. So the derivative of this exponent is negative 2. Is that okay with you guys? And then the denominator, the derivative of this denominator is 2x, right? Because x squared, it becomes 2x. A constant becomes 0 if I derive them. Let's make this prettier. This is g prime of x plus, I'm sorry, it's actually minus, right? Because 3 times 2 is minus 6. E 12 minus 2x divided by 2x. I know it's a lot to take in, guys. I know this is jumping around from unit to unit, and don't let it discourage you guys. And what do we do once we find out that we derive this? What should we do? Well, we try the direct substitution one more time, right? So with direct substitution, if I substitute the limit as x approaches 6 one more time, this is g prime of 6 minus 6e 12 minus 2 times 6 divided by 2 times 6. All I did was substitute x equals 6. But I'm very, very concerned on this part right here. G prime of 6. What is g prime? Well, remember, if we go ahead and look back, onto what just g is, right? This is just basic g. So g prime of x is the derivative of this, right? So the derivative of this is just f of x. So in reality, we want to find f of x at x equals 6. What does that mean? Well, that means you just want to find the y value. Y value at x equals 6. Super easy, right? So what is the y value at f equals 6? So what is this y value right here? 0. So we got 0 minus all this good stuff. Oh my goodness, looks scary, but really doesn't. This is minus 6e, and then this 12 minus 2 times 6. Guess what that is, guys? 6e to the 0 divided by 12, which in reality, we just saw that e to the 0 is 1, so it's negative 6 divided by 12, so negative 1/2. Now, I want to go ahead and mention something to you guys. If you know that, hey, the algebra is gonna be like, hey, that's gonna be the part that like knocks me down. As long as you don't leave anything in the function form, right? Like this g prime, it wouldn't have worked. This f prime, it wouldn't have worked. But if you would have left it as just simplified version, which we said this right here, you're golden, guys. You don't have to simplify. Like as long as you're not talking about functions themselves, you're talking about actual numbers, you're good. So I just wanted to show you that it wasn't that bad, but it's completely up to you. Any questions, guys? Yes, no? Okay. How much time are we at? 35. I'll start this one now. Okay. The next one, guys, it says evaluate this integral from 1 to 7 given all of this right here. So it looks very, very like crazy. Like it looks real bad, right? So what I want you to know, guys, is that there's rules to these integrals. So we can go ahead and break it up, right? 1 to 7. This 3 is only affecting this function right here. So I'm going to put it on the outside. H prime, what the heck is that? 2x minus 4. And I'll break it up into two parts. This is part A, this is part B. So plus the integral 1 to 7, 5 dx. Any questions on that? Okay, that should make stuff a little bit easier to do. But I want you to know one thing. We don't know a little bit of these things. So before I start integrating, guys, I'm going to go ahead and make this part a little nicer. So we're doing the same thing, but I want you to think about the function that we're working with. Sorry, this is with d with respect to dx. This right here, guys, I recommend you to do use substitution, because this right here, if I derive it, it becomes 1, and I could easily find the 1 right here. I'm sorry, a 2, but I can easily make it into 2. So use substitution, 2x minus 4. And if I derive this, I just get 2. However, there's no, I'm sorry?
I usually don't flip the -7 and 1 because it's positive or negative.
It's not -7. It's just +7.
Oh, it's +7?
Yeah, but yeah, if it was negative, you would flip it, correct?
What does it show negative then there?
That must be like the font or something, but it should be a +7.
Okay, sure.
Okay, so what I want you to see is that I can go ahead and make this easier on myself, because I got H's, I got X's, I got so much stuff going on, but I can make everything in respect to U if I integrate. Okay, so if I derive this, it became my U, and if I derive my U, it became my du, but I don't see a 2 anywhere on this function, except for the U, but our U is the U. So in reality, it's gonna be, we have to divide by 2, because I do see a 1, right? A 1 in front of the H prime. So if I divide by everything, so it's gonna be 3, the integral H prime of U du divided by 2, right? Because du is divided by 2. Now, there's one dilemma. Since we're leaving everything in terms of U, we can no longer have these same limits of integration. So it's no longer 7, it's no longer 1, because it's no longer in terms of x's, it's in terms of u's. So all you have to do is substitute the limits, the end limits, the 1 and the 7, into u. Okay. So this right here, if I go ahead and put the 7 into the x's to get in terms of u, it's 2 times 7 minus 4. So 2 times 7 minus 4, 14 minus 4 is just 10. And I do the same thing for the 1. 2 times 2, I'm sorry, 2 times 1 is 2, minus 4 is just -2. So we can write this a little bit nicer. This is actually 3, -2, from -2 to 10. H prime u du. Any questions on that, guys? So all I did this is just to make sure everything's in terms of u. So this right here is a property that we can do, guys. If you want to leave everything in terms of u, you just have to make the limits go inside u as well. And we can just drop all of this down, right? Plus,
What's the
yes,
denominator for the 3 over 2 negative 2?
the denominator.
Look at the 3 over 2 negative 2.
This one? Oh, snap, I see you right here. It's just 2, sorry. Thank you.
Yeah.
That makes sense. Okay, now it should be a little bit easier. So this right here, we can go ahead and integrate everything. So if I integrate everything, it's just the value here, 3/2. If I integrate this part right here, something that is prime, well, actually I just get h of u, right? H of u, evaluate at the limit -2 and 10. And if I integrate this one, it's not that bad. This was the easier part, f of x, evaluate from 7 to 1. This one, the limits did not change, guys, because this is still in terms of x's. We didn't mess with that one. So all we have to do now, guys, it's not that bad. We just have to go ahead and substitute everything that we know. So do we know what h of u is? This right here. So actually we can go ahead and just use the function itself. H is 10. So we're gonna go to our piecewise function, right? H10. And you're gonna find out when the u is 10. We're gonna use what? When u is 10, do we use the left or the right? Because 10 is in here. Does that make sense? So I think this is the trickier part, guys, that we need to go ahead and notice what part are we really using. So it's saying you need to use u is 10, right? Because that's the top limit. But unfortunately, u of 10 is talking about g of 10, which is the integral, the area from 2 to 10. The area from 2 to 10. What is the area from 2 to 10?
-1.
It is this area, right? This area right here and this area right here. The area is -3, right? Because the 3 is below. This is negative. Plus 2, and as Albert mentioned it, this is -1. So for my g, let's see if I can make this a little bigger. What happened? For my g, right, this is 3/2 h of 10, right? Because if we minus the top minus bottom, remember fundamental theorem of calculus? Remember FTC? F of b minus f of a? That's what I'm doing right here. So it's 3/2 on the outside. I'm not gonna mess with that yet. And then we set this area h of 10. We did it right now. We just said it was -1 minus h of -2. So I go back to my h function where my u is -2. So which side am I going to use, the left or the right?
Left.
Yeah, so I'm going to put -2 into here. So it looks like it's going to give me 4 minus 6 minus 2. right? Because if I put this as 2 squared, 3 times 2 is 6, but it's negative minus 2. So it looks like it's going to be what? Negative 4? Question mark?
Yeah.
So minus a negative 4. Okay, all of this is fine. So we have 3/2 minus a minus. So what does that give me? That gives me a 3/2. Negative negative makes a positive. So 1 plus 4 gives me 3. Yes.
Yes.
So that gives me 9/2 question mark.
Yes.
And then we just have to do this final part. So f of 7 minus f of 1. So 35 minus 5 is 30 positive. So my answer should be 9/2 plus 30. So how are we feeling, guys? How is this so far? It's intense, right?
Underwhelming.
So yeah, that's what I thought so too first. So I was like, dang, this is a lot. But what I want you to know, guys, is you don't have to get every part correct, every single step correct to get all the credit. So I think I'm gonna go ahead and pause right now, and I'll make the separate video a little bit later, and I'll attach both. But the next one is differential equation. So I encourage you guys to do it because this is just what we learned before. This is from unit 7. Remember the differential equations. Oops, I should have done that. Dy dx, right? H prime of x, y minus 1. And remember, first you separate the variables. Second, you integrate. Third, you find c given the initial conditions, stuff like that. So I want you to try that one. Since I feel like this might be a little overwhelming, because I know when I first saw it, I was like, oh my goodness. But ideally, this is not. I don't want to say this is what they're gonna do, but since